Hello there, Mr. Vessel here today, and I'd like to take today's video and look at 2000 P Statistics number 4. And what this problem is about is doing a confidence test or a hypothesis test with two different, attacking this with a significance test method, but it could be done in either way. And this problem is about basically two different medical procedures. So the ACL is one of the ligaments that help stabilize the knee. Surgery is often recommended if the ACL is completely torn, and recovery time from the surgery can be lengthy. A medical center developed a new surgical procedure designed to reduce the average recovery time from the surgery. To test the effectiveness of the new procedure, a study was conducted with 210 patients needing surgery to repair a torn ACL, randomly assigned to receive either the standard or the new procedure. And Part A is based on design of the study. Would a statistically significant result allow the medical center to conclude that this new procedure causes a reduction in recovery time compared to the standard procedure for patients similar to those in the study? Explain your answer. So I think the key with Part A, not even getting into anything except the design of the study first. So the way that they designed the study was, we got this 210 people, and they all had needed a torn ACL repaired, and this part's key, randomly assigned to either receive the standard or the new. So with Part A, because of the randomness between these two procedures, we can say that this study, if there is significant difference, can be caused by this new procedure. So we do want to say yes here. Yes, the researchers could claim that a significant result would allow the medical center to conclude the new procedure causes a reduction in recovery time. And basically, when I try to write these things out, I want to use a lot of the same language that was used in the prompt here. So just trying to basically parrot back what the question was. It just really helps me make sure that I'm staying on task and answering the appropriate question. So and we just have to mention why. So all we've said so far is yes, but the reason has to be about this randomness compared to the standard procedure. This gets it in context. Keep spelling the word procedure wrong. Procedure, because the patients were randomly assigned to the two groups. And that's really it for Part A, just making sure that we keep it in context, we answer the question, and then the fact that it was because of the random assignment that caused this to have possible causation here. Alright, now the fun one. So you get into Part B and you get the summary statistics, and we see do the data provide statistical convincing evidence. Now in this case, I think it's going to be just better to do a two-sample difference of means t-test here, mostly because this is a one-sided test here, and it is possible to do a confidence interval and just see what do we think the confident, or how confident we want to be, and we can make a confidence interval for the difference between these two means, and we could interpret or conclude this question using that. But I'm going to go with the two-sample difference of means t-test here, and I think that's the most common approach to this kind of task. So what we're going to check for is basically, is the new procedure giving us a lower mean number of recovery days than the standard procedure? And I mean, obviously it is lower, but the question is it significantly lower? So what we're going to do is do a test and find that out, and we're going to start with a hypothesis. So, let's move this down a little bit. So we're going to make a null hypothesis, and we're going to make an alternative hypothesis. I'm going to use, let's start with the procedure for the standard. So we're going to test, we're going to assume that the mean for the standard procedure is the same as the mean for the new procedure. And I'm just going to make sure I define these parameters. We can't use these symbols without defining them. And then the alternative hypothesis is that the new procedure is less, so that the standard procedure will have a greater mean. So mu of s here, this is the mean recovery time for ACL surgery with standard procedure. And use the letter N for new here. So the mean recovery time for ACL surgery with new procedure. It's important to define those just to make sure that the grader knows what you're actually going to do the test with. And then, once we've got our hypothesis named and labeled, we next need to actually name the test that we're going to perform to test these two hypotheses here. And that's going to be a two-sample t-test for a difference of means. So in this particular case, we got the two samples. We're subtracting the two means to see if there's a difference between them, and we always use t with means. And the reason is we don't have sigma, and whenever we use means, it's always safe to use a t-test here. So the formula for that is going to look like this. T equals, we'll take our sample mean and subtract them. I should have mentioned too, there's definitely other ways to break that null hypothesis. We could have used the difference equals 0 for the null hypothesis. Sometimes that's a nice way to go about these. And then the difference is greater than 0 for the alternative hypothesis. And finally, we have to divide that by the standard deviation. Remember the variances add here. So we're going to use the standard deviation squared over the sample size for the standard procedure, and add the standard deviation squared for the new procedure over the sample size for the new procedure. But before we can actually calculate this and look it up, what we're going to need to do is just make sure that we can do this test, because there's some conditions that need to be met. And to check the conditions, there's a few of them here. So the first, it doesn't matter what order, there's two conditions we basically need to make sure of here. So the conditions, we got to make sure that it was a large enough sample. In this case, that is met. We have to make sure that each sample group is bigger than 30. In this case, that's true. So we have greater than or equal to 30 in both groups. So this distribution will be approximately normal. And then finally, the other one is that the random samples here. So that was met too. So we had the random assignment of treatments. that was met. And that was given to us right from the beginning, so we knew that even from part A. So that random assignment's important. We have to have that large sample, and sometimes it's good to even just say what these two sample sizes are. So we had this 110 for the standard procedure, and we had this 100 for the new, and both of those are going to meet criteria for large enough samples. So now that we got those out of the way, we can actually calculate our t-score, and we're going to use these values up here. Just plug them in here. So t, let's see, 217 minus 186, and the null hypothesis is 0, so I'm not going to write that part down. Divided by the square root of 34 squared over 110 plus 29 squared over 100. And we're going to type all this in. Oh, meant to switch color there. And once we get that t-score, we'll be able to look that up in our t-table. And let's see here. So let's start with a fraction. 217 minus 186, and then 34 squared 110 plus 29 squared over 100. And we get this t-score of 7.127. 7.127. It's a very large t-score, but we're still going to look this up and make sure that this is significant here. So this has a degree of freedom. We're going to use the safe one here. There's actually a couple of different versions for the degree of freedom. The degree of freedom that's safe is going to be 98. That is n minus 2 from the smallest sample. So there are formulas that combine the two. Excuse me. But the safest and probably the easiest to remember is just using the smallest sample, in this case 100, take away 2 for the degree of freedom here, and you can find that 98 is a safe degree of freedom. And when we go to our t-table, we're going to go to the spot on the table. There is no 98 in your table here, so again, here's another safe thing to do. You go to the one that's lower, so we're going to go to the number 80 here, but it doesn't even matter what we choose. Whatever we look up over here, 7 is way off the chart. 7 is way the heck out here. So all I can really say is that my p-value is less than 0.0005 based on this table. It's probably really, really close to 0, and I think it'd even be perfectly fine to say that it is approximately 0. But according to the table, I'm going to use that the p-value is less than 0.0005. And in this case, it's very significant at pretty much any level we'd want to use. Basically what this tells us is that this difference is extremely unlikely if this true mean difference is 0. So that we get this difference of about 30 days. I guess it's 31 days. So we get this difference of 31 days, and then that's a very significant difference compared to the number 0, basically. So that's how we're going to conclude this. And in order to do that, we just want to make sure that we compare this p-value to some alpha level. Let's use 0.05. That's probably the most common one. So at alpha equals 0.05, this sample difference, you can say it's highly significant. There is evidence to reject the null and accept the alternative hypothesis. And what that tells us back in context is that the new procedure has a significantly lower mean recovery time. For torn ACL surgery. Again, some of the key points to making a conclusion: it's really important to compare your P to your alpha, and if they're both on the paper at the same time, then you don't have to restate that this is less, this p-value is less, P is less than alpha here. And the other part to this, we want to make sure that we get it back in context and say what it means in this particular situation. So it's more than just saying we're reject the null. We got to be able to put that back into context. So in this case, what that tells us is that the new surgery is significantly quicker recovery time than that old procedure is. So that's the nuts and bolts of the 2018 number 4 question. Thanks for checking this video out. Hope you can check out more, and have a great day. Thank you.